All right, Lauren, this is mostly for you because one is here, and basically you're the only two people registered, pre-registered in the class. Neither one of you are paid yet, so guess what? They're not going to let the class run with no paid students. So if you are going to take the class, if you're serious about taking it, please get paid as soon as possible. Otherwise, they're not going to let it run. But I was just telling one, an advantage to taking it now, and I was wanting it to run it this time, is that this is the last time that that Cal 2 will be offered using this text, the one that we used in the summer, Rogowski and Adams. Because starting this term, Calculus 1 students are in new text. It's the Larson text, okay? And did you take Math 112 and 113 here?
I took it at Jump State.
At Jump State, okay. What do you remember what book they used? Was it Larson?
We didn't use a book.
You didn't use a book. Okay. All right. Well, anyway, it's the same guy who does our 112 and 113. He's a very good author. I don't like the publisher, but I like the author, and he has lots of supplementary materials online and that kind of stuff. So I think it's going to be a good book. But I don't know, Lauren, if you even purchased the book. If you didn't, it probably isn't going to matter to you whether you use this book or next. But you have purchased the online version of this.
I got it for free online.
It's free?
Yeah.
How did you get it for free?
I just type in the name of the title,
Uh-huh.
put free PDF, found it.
Oh, really? Nice. Well, would you be able to do that with the other text too?
I'll have to look online.
Okay.
Laptop.
Well, the other reason I wanted to run it, and this is mostly for one, though Lauren, you too, but you're a student at Auburn, but one, you're a Lawson student, right, now? I hate for you to miss a term without a math course. So, what is your feeling on it right now? If it's just you and me in the classroom and Lauren doing it remotely, are you okay with that? Or would you, another option would be, I've got Math Calculus 2 recorded on YouTube already, and you could do that and then come and ask me if you have questions. Or I don't mind teaching the class just the two of us. I don't mind that either, to keep you from having to wait another term and do Cal 2 in the spring. What is your feeling on that?
Well, I can't wait for another term.
Okay.
Because my plan is to get Calculus 2 over with in the spring with Cal 3 and linear algebra.
Okay.
And in summer, offer differential equations.
Right.
That way, when I went back to Huntsville,
Right.
I got math over with.
Right.
And so physics.
Are you planning to going to UAH? Is that what you mean, or A&M or what?
Next fall, I plan to go to UAH.
Okay. And you can come in the summer. So you need this one this term. That's what I was thinking. Not that you would need it, but that whoever was in it would need it. So that's why so would you rather try to do it self-study using the YouTube or have it in class? I don't mind doing it in class. I got the period free, so.
I mean, I guess it's up to you. So it is your time, but either way, I still have to come here on campus to watch the videos because I don't have internet at home.
Okay.
So yeah.
Yeah. Which would you prefer? Being in class or trying to do it not in class?
If it's not too much bother for you, I guess I prefer in class.
Okay. I'm fine with it. I'm absolutely fine with that. Okay. So then we'll proceed now, but gotta get paid. Okay. All right. So are you originally from Huntsville or?
No, I'm from McCullough.
Oh, okay.
Yes, sir.
But you're planning to go to Huntsville. Okay. All right. Then enough of that. Let me close this out. And because I didn't know what was, oh wait, I went to the wrong thing. Onto this. Okay. Math 126 syllabus. I haven't updated the syllabus because I wasn't sure if the class was going to run or not. But if you need it, and it sounds like you do, we will run it. That's all I needed to hear is that you needed to graduate. So this is updated. This still says summer 2017. It's now fall 2017, if you hadn't noticed. Okay. So, it's Math 126, Cal 2, 4-hour course. Now, this part about the class meeting days and time will have to be changed. Right now, let's see, where is that? Monday, Wednesday, 9:30 to 11:10. Right?
Yeah,
Okay. 9:30 to 11:10. And it'll be in this room, A255, this building, and this campus. Okay? My name's still Charles Fowler this term too. Okay? I'm not going on an alias now. My email is cfowler@washingtonstate.edu. My phone number is 929-3449 here on Bessemer campus, and 929-6409 on the Birmingham campus. I'm here Monday through Thursday, Birmingham Friday. Okay? Now, please, okay, let me back off. Email address. Right now, I'm way behind on emails, so don't be expecting immediate response. I'll try to as soon as I can, but we were out for a week, and I was out of state for most of that week, in fact, all that week, and we had really lousy internet where we were, so I couldn't keep up with things there. And then last week we were in meetings and all sorts of things, so I got behind in email, and I haven't had a chance to catch up. So I'll get caught up as soon as I can, but don't expect immediate answers yet. Phone messages, I think I told you this in the summer. Don't leave me a phone message at the 6409 number. It's not my phone. It's just the number in the office where I am on Fridays. But it's somebody else's phone. So she's the only person that can get the messages. I can't. Okay? So please don't leave messages at that. And on the Bessemer one, the 3449, only call during my office hours. Because when I'm in class, I can't hear the phone ring. Office is way down there. Even if I could, I wouldn't stop class to go answer the telephone. So only call during office hours, and if you don't get me then wait a few minutes and call again, because I'm just out in the hall, restroom, getting a drink of water, something. I'll be back soon. Okay. Now, my office hours are not correct here. Let me give you from memory what I think they will be. Okay, as soon as this class is over with at 11:10, I have right at an hour for lunch. So you can contact me then. Most of the time I bring my lunch, I eat in the office, so that would be a possibility. Now, immediately after that, starting at I think 12:15, I believe that's correct, I have Cal 3. Now that course, I'm more inclined to let that one be canceled because they're in this book, but we'll still be in Cal 3 in this book in the spring. And if we can combine that class with you and maybe Lauren and anyone else we may pick up, then we'll have a bigger class. So I'm hoping that we'll be able to cancel that. But if someone like you has to have it to get the sequence in before they graduate, then I'll run it then. And you and I may be along next term as well, so we'll see. Okay. So anyway, at what time did I say that was? 12:15 is when the calculus class is. I don't know what time it ends. But then at 2 o'clock, my differential equation class, I think that's the one that meets at 2, and it only has a couple students in it, so I'm hoping that one, I can cancel that one as well and combine that with students in the spring and have bigger classes. But if someone needs it and they're graduating this term and they have to have it, then I'll run it. So I can't tell you what my office hours are, but I can tell you this. From 3:15 until 5:15, I have office hours. Free office hours. Now, let me take that back a little bit. Except for today, I'm going to have to leave a little early because I was supposed to be in Birmingham before 5 o'clock. So I won't be able to be here till 5:15 if I've got to be there by 5. So I'll leave a little early today, but most days it'll be 3:15 to 5:15 on Mondays and Wednesdays. Wednesday it should be 5:15. I don't think there'll be any problem with that. Okay, Tuesday, Thursday. I have an 8 o'clock class, a 9:30 class, and an 11 o'clock class. The 8 and 9:30, those classes are made. The 11 o'clock class, again, is a very small class. I think that's the linear algebra. And if I could put that off until next spring and have a bigger class, then that would be fantastic. Okay, but I won't know that until I talk to the students today. Tomorrow. But then at 1:15, I have OL. Okay, so from 12:15 to 1:15 is my lunch, and that's all the office hours right now that I have on Tuesday and Thursday. Okay, but you can come see me during lunch because, like I said, I bring my lunch and I eat in my office. Because at 1:15 for the first mini term now, 1:15 I have a physical science class because the mini term class 1:15 to 3:45, and then lab from 3:45 to 5:45. So if you catch me after 5:45, I'll be around the office another 15 minutes before I go home at 6. So that's all I got on Tuesday and Thursday now, unless that linear algebra counts. So I got to find out that before I know for sure. Then on Friday, I'm on the Birmingham campus, 7:45 to 11:45. Now I may extend that a little later when I figure out how many hours I've got, and do adjusting because my second midterm I've got a physical science 2 class that I'm getting paid overload, and I have to account for those hours, do extra hours. I may do some of those this first midterm, not do the whole second midterm. Okay, so Friday, 7:45 to 11:45, Birmingham campus, academic building, 122. Are you familiar with Birmingham campus? No. Are you likely you'll come by on Fridays? Probably not. So if you do need to get directions, let me know ahead of time. Okay. All right, course description, the second course. Now, I did change something here. We're not supposed to change this. I think they may have updated it since I thought, but back when I first did this, they had this as the second of T courses, T-E-E, like a golf tee. I knew that was wrong, so I changed that. The second of 3 courses in the basic calculus sequence. Topics include vectors in the plane and in space, lines and planes in space, applications of integration such as volume, arc length, work, and average value, techniques of integration, infinite series, polar coordinates, and parametric equations. Is that enough? That's a couple courses worth, it seems like. So what we're going to do, we're not going to do it in this order. We're going to do it in the order that it presents it in the text. And I take it you don't have your computer or anything with you today. So now, I need you to help me out on this. Well, I think I may have it marked here. I think in the summer we made it through section 4.6. That's where we ended. Okay? We weren't going to do 4.7 anyway. And I would like to show you 4.8, Newton's methods. So actually, I'm going to back up a little bit and do this because we lost, what was it, a week and a half in the summertime because various things out of 10 weeks. So we were really only had about 85% of the class time that we needed. So I'll quickly go for 4.8. It's a very short section, just so you'll be exposed to it. And I think that's the end of 4. So that will be done probably not today, but maybe Wednesday. Okay? If we can get it done today, we will. Okay. And we didn't get to start 5 at all. And 5 is actually not too far from where this 5 is the integral, which we should have started, but we didn't get a chance to. But it said the first 5.1 is approximating and computing area. And if you'll notice right here, let's say it. So what I'm going to do is go through 5.1, just a slideshow, without making many assignments in it. Okay? Just so you'll be exposed to it. And 5.2 is the definite integral, which we should have covered before, so we'll do that. And I'll try to do it as quickly as possible, but I won't go too fast so you don't understand it. 5.3 is the indefinite integral, okay? And again, that's not a huge change, but it's, a little bit. But there are things you need to know there. 5.4 is Fundamental Theorem of Calculus Part 1. And that's a pretty short section. It'll just do slideshow. And Fundamental Theorem of Calculus Part 2. And we'll do that slideshow. Okay, and that's a very short section. All right. 5.6 is net change as the integral of a rate of change. We'll probably skip that one. That's a sort of I may just do a quick slideshow. It's real short, so I'll probably just do a slideshow on that. Then 5.7 is substitution method. To me, this is a technique of integration. So this is where I'll start the class as far as this. But we've got a lot of stuff to cover just to get you up to speed so we can do substitution. Because you haven't done any integration yet, right? Okay. All right. So that's what we're going to do. We're going to fly through the end of 4.8 and then the first part of chapter 5 until we get to 5.7. And at that point, really the course begins. Okay. So we'll try to go as fast as we can on that. All right. So we'll do that first. Then I should just use this table of contents. It's a lot faster than doing the book. It says further transcendental functions. Yeah, we need to do that quickly. 5.8. We'll probably skip 5.9. And then chapter 6 is application of integration. Okay? And as you see here, it says area between two curves, and that's where the area was coming into play. Setting up integrals, volume, density, that's where these come into play. Volumes of revolution, that's another application. Method of cylindrical shells, that's an application. And working energy, and you see working energy is mentioned there. So, your first test will be substitution, technique of integration, and applications of integration. All right? Chapter 7 will be the next test, and that's techniques of integration, which is what they say here. Okay? And we'll do integration by parts. Most of chapter 7. Not all of it, but most of 7. And then this book does chapter 8, goes back and does some other applications of integration. Because you really need some of those techniques to do some of those others, okay? And that's where you get the arc length that you see there, surface area, they don't mention there, but we'll do that, and fluid pressures and force, they don't mention that here. May skip center of mass, we'll see. What's your major, by the way?
Civil engineering.
Civil engineering. You might need to know center of mass, so we may do that, okay? Chapter 9 is Introduction to Differential Equations. Guess what? That's a different course. So we're not going to do Chapter 9. Chapter 10, though, is Infinite Series, which you see right here. We'll only do sections 1 and 2. And then Chapter 11, Parametric Equations, which you see right here. And we'll only do 1 and 2. That's parametric equations and arc length, which we already have mentioned before. And then Chapter 12 is vector geometry, and that's what these are. Vectors in plane in space, lines in plane in space. Okay? And we'll only go down through, if we even have time to get this far, we won't do 12.6. 12.6 is where Cal 3 starts. Quadratic surfaces. Okay? So basically, we're going to do slideshow on the end of 4 and most of 5. Beginning with 5, 7, and 8, you'll have, that will be covered in the first test with chapter 6. We won't do all of 6. Well, actually, we do most of 6. Okay? And then chapter 7 will be the next test. And then beginning with 8, we'll do 8, 1, 2, and 3, 9, 1, and 2, 10, 1, and 2, 11, 1, and 2. And that will be the next test. And then vector geometry will be the last test. Okay? All right, if we get that far, because Don't have to really move to do that. But since my class is such a smart guy, we'll go really quickly, won't we? Yes. Okay. All right. Prerequisites, co-requisites, none. Prerequisite is 126 has a prerequisite of 125. Okay, basically, you've already had that, and so has Lauren. Textbook, we're going to use the same textbook we did. Lauren, I don't know if you used it or not, if you had it or not, but that's one reason we're going to continue with the course, because next term they go to a new text. In fact, Cal 1 is already in the new text now. Okay, then Blackboard, I think you've heard that one before, so do I have to read that through that again? I make fun of that paragraph, okay? Don't laugh, okay. And then next, the student course learning outcomes. We'll be able to apply definite integrals, which we have to get that to volumes, arc length work, and other applications. That's basically Chapter 6. Students will use different techniques of integration, such as blah, blah, blah. That's Chapter 7. And students will work with infinite sequences in series. That's 10.1 and 10.2. Students will solve parametric equations and use polar coordinates. Now, the polar coordinates, I don't think were in the course description, were they? I don't believe so. Yeah, it was, so we will need to at least touch on polar coordinates. So that may be 11, 1, 2, and 3. We'll touch on 3. We're not going to do a lot with that. And then students will use vectors in the plane and space to define lines in plane and space. That's the first part of Chapter 12. Students will research. Yes! And write a paper. You remember how much fun that was? Okay, I needed it, okay. On the topic, or computer application in calculus. Okay?
Reuse the one from the summer?
No. Dream on. Slap yourself. You're dreaming. Wake up, wake up. Okay. All right. The core competencies here. We'll do Chapter 5 and 6. Substitution and application of interval, but I've got to bring you up to where we need to do so. It'll be in the 4, 5, and 6. But the test will be just on 5, 7, and 8, and most of 6. Chapter 7, technique. Chapter 8, further applications. We'll do 3 sections of that, 2 in infinite series, 2 or 3 in parametric equations, and then as many as we can get to it. The writing competency will be your research application. The overall competency will be your last exam, which will probably be Chapter 12 exam. Okay? You'll be using everything pretty much we did. So you hopefully remember the grading policy. Your research paper counts as a test that cannot be dropped. Different paper, new paper, by the way, since some people might think otherwise. Okay? And your last test cannot be dropped. The final exam cannot be dropped. Any of the middle tests, I will drop the lowest of those if they help you score. Okay? I think that did help a score, if I remember from last term. Yeah. You had skin on your teeth. Do you remember? You know the saying? Made it by the skin of your teeth? Okay. All right. And then 90s are A's, 80s are B's, and all that. Okay? Attendance, you better be here because I'm going to be here, right? All right, good deal. Lauren, I don't know if you're going to be here or not, or you're going to try to do it all remotely, but I will need to hear from you, email, phone call, something or another. Otherwise, I can't count you as being in the course. And if you're not in the course, they'll drop you from the course. So please communicate with me somehow, some way, as much and as frequently as possible. We'll work out how to use. I mean, you send me your research paper, you're counted as present that day. Send me a test, you certainly are counted as present that day. So we'll have to work out how we're going to do that. I think we'll just email them back and forth. That would be fine. Okay. Any questions on attendance? Okay. Makeup work, since they're all going to be Take-home assignments. How do you do makeup work on take-home assignment? Get them into me. Once I've given out a test, please try to get it back. Try to get it back within a week, but if not within the week, before I give you the next test. I don't want you sitting there with 2 or 3 back tests. That's not good for you, and it's not good for the, just not the way to do things, okay? So try to get it within a week or before the next test. I'm going to try to start all the classes on time. Usually I have a Math 100 right before this, so I will be right here, so there shouldn't be any reason not. Statement on discrimination and harassment. Any questions on that? We went over it last time. What's that? Good. Okay. And Lauren, if you have any questions, please get in touch with me. But there it is. By the way, the syllabus is not on Blackboard yet, because I wasn't sure if the class was going to run, but now it will because one needs it, and he's important. He's special. Okay. So I'll run it just for him. Okay. So we will be having class, and I'll put everything on Blackboard as soon as I can get everything updated, like on this. And I won't know about updating until after tomorrow, where I find out my Tuesday, Thursday classes, which are going to make and which are not going to make. So it'll be later in the week before I have that out there. American with Disability, this is current. There should be no changes here. So any questions on that? Okay. The campus calendar, this was last summer's. I'll get this updated as well. I have the new one done, but I just don't have it copied onto here. I'll get that moved over here whenever I can get a chance, and that may be Friday or so. I don't know. Hopefully before that. And then at the end, here's the student acknowledgement form. Once I've got it out there on Blackboard, if you'll either print this page or email me this page that you have understand what's required in the course. Any questions? Okay. So I will go on and can that. And this is where I need to get it back to this and find the research paper now. Nothing much has changed since last time, but I'll go over it again just to refresh your memory, because it seemed like that some people were already forgetting it toward the end of the term anyway. I do have a couple of changes to make to this. They're pretty minor, but I will make them. Sorry, my head's a little clogged up. Having trouble breathing some, but hopefully this will open. Well, I thought it was opening, but I sure don't see it opening. Do you? So let's try it again. Well, let's see. Maybe it's here. Nope, it's still trying to open. This is usually a little scary when it does something like that. Sometimes you have to sort of jog it a little bit. It says it's okay. So close this out. Alright, I don't know why that's not opening. I think I'm going to close it and open it again. See if it'll open this time. Word, Microsoft products just drive me crazy because they're, so there we go. All right. Let me full screen this. No. Yeah, let me try that. There it is. Yeah. There we go. Full screen that. Okay. Research paper, general instruction. You choose your topic. Different from last term. Okay. And as you know, it can be a person in theory, phenomenon application, any other thing such as that. It can be an internet application or demonstration, just like it was you could have done last time. But you will sometime. Now, here's something new they're asking us to do now. Remember last time I said you may or may not write phone numbers or anything? This term they're wanting us to get your preferred email and your preferred phone number. So when you give me your topic, write that also, your preferred email. If it's Lawson State email, fine. Write it, just say Lawson State email and I can get that. If you prefer that we communicate with you through a different email, let me know that. Okay? If you have a preferred phone number, let me know that. And then if you want to give me any backup phone numbers, you can, which could be home number or place of work or whatever, any others that you do. But they are asking us to get preferred email and preferred phone. Okay? Because quite often the system, people don't check their Lawson email, and we need to be able to communicate. And sometimes the system doesn't have your latest phone number. Okay. So if you will do that, write your topic, name, and at least those two pieces of information in the addition they want. The source needs to be something outside the text. In the very first chapter we do, I saw a couple places there where they had historical perspectives. That may give you an idea for the topic, but you can't use that as a source. You need to find the source outside the text. Okay? But you can do anything from the library, books, journals, articles, newspaper, whatever, or you can use legitimate materials found on the internet. Remember, not everything on the internet is right. It's quite often not. Okay, so be sure you use something that is well documented. Your paper must be at least one word process page, double space, 12 point or 12 pitch, however you want to call that font. The font you use is up to you as long as I can read it. And let me go over what constitutes a page of text. Notice some people didn't seem to understand this last time. Okay? If you have a header, which I don't require, but if whatever you're using as format requires one, that's fine. You have a header up here, that's good, and a title here, usually triple space or something there, and you start typing right there. Okay? And you're using the right pitch, and I want it double space. This is single space, so double space. But you'll go through the bottom of that page, onto the next page, and down, type down. You've got to get at least that far on the second page. So even though it says one page of text, that is going to, by necessity, be at least two pieces of paper. Right? Okay. So that's one page of text. Okay? Fonts I can read. You will lose points if it's less than a page of text, a full page of text. But there's no penalty for it being longer than 2 pages, or at least not any direct penalty. Okay? And it's not meant to be a penalty. But when I grade your paper, I start off, it's a 100-point paper. Okay, I can hear you now say, well, don't read it. No, just write it down right there. No, I'm going to read it, okay? And as I go, if I start finding errors, you start losing points. Now, if it's a good paper with very few errors, it's going to be a good paper, whether it's 1 page, 2 pages, as long as you want to make it, as long as it's a good paper, it's going to be a good paper. But if you have lots and lots of errors in it, and you just keep giving me page after page after page of lots and lots and lots and lots of errors, you are losing lots and lots and lots and lots of points. So make sure it's good. Don't try to substitute quantity for quality, is what I'm saying. Okay? Not that you would do that. Right.
Happened to me in art.
Huh?
Happened to me last fall with art.
I'm sorry.
In art class,
Oh.
I went for quantity to quality.
Yeah.
So that messed up my grade.
Oh, it did? Okay, so I'm not the only one that does that. Huh? Okay.
Yeah.
All right. You can use any format, MLA, APA, whatever you choose, but stick with your format. Be consistent. Like I suggested, if you start blocking your paragraphs, block all your paragraphs. If you start indenting your paragraph, indent all your paragraphs. If you start in one font, don't switch to another font at a different paragraph. Unless there's some reason, like if you're doing something that needs to be italicized, that's fine, but then go back. Yeah. So be consistent. Okay? Spelling, grammar, sentence structure, all that kind of stuff, they'll cost you points if they're errors. So please use spell check, grammar check, good proofreading, and all that. Content also matters if you have inconsistencies in the content. And most topics that you choose, I will be somewhat familiar with. And if you tell me something that's absolutely wrong, then either you're trying to pull the wool over my eyes or you got a bad source that you're getting the paper on. So try to keep it clean. The paper is due by the last day of class. That's not the last day of final exams, the last day that we're in class, which I think for this class will be a Wednesday in December, probably the first Wednesday in December. So that's not final examination week, it's the last week of class, okay? Try to get it to me as early as possible because I think I went through this with you before. The end of every term, everything piles up. And if you put off your paper till the end, you're not going to have time to do a good paper. And you're just going to throw something together and turn it in, maybe without even proofing it very well. And that's always pretty disastrous, unless you're naturally a great writer, most of the time that will not do you well, okay? So try to get it in early. I do this now. Everything will change for the term here. But December, if you turn it in December, you just get your score. You turn it in November, you get 1 bonus point. You turn it in October, you get 2 bonus points. If you turn it in September, you get 3 bonus points. And if you turn it in August, which you only have, this week and next, you get 4 bonus points. So there's the carrot. The stick is you start losing points if you turn it in late. Okay. When you submit your paper, please attach a single page from one of your sources. I forgot to say this. You will need outside sources, not your text. And 1 is okay, 2 or more are better. But whatever you have as your outside sources, please attach a single page from that source. Now, if you do your paper on a computer application, a link, and that's all you've got, then you can't really do a page from that, I don't think. So you can just provide the link. But it has to be pretty obvious that's what it is. Any questions or? Okay. There's all my information. Okay. So I'm going to minimize this. And locator card, I think I did. So let's. Come on. Oh, there it is. I see it. I was looking for. All right. I think this is updated, but it may not be correct until I find out if any of the classes get canceled. All right. Start with my name, phone number, email address. Okay. So here, whoa. All right. On Mondays and Wednesdays, I have Math 100, big class, full class, 8 to 9:15. Then this class will be Monday, Wednesday, 9:30 to 11:10, Monday and Wednesday. Then I have lunch 11:15 to 12:15. Then if it runs, the Cal 3 will be in the afternoon. I'm kind of hoping those students can postpone it until the spring, and then you can add to that, and we'll have a bigger class. Okay? But if they can't, then I'll run it, and we'll probably be all by ourselves again in the spring. So that's okay. Then differential equations, same thing. If we can put it off and have it in the spring, I'd rather do that because this is low numbers, and hopefully we'll pick up some more people in the spring. But then at 3:15, that goes 2 to 3:15. At 3:15 till the end of the day, which is 5:15. Except today. Today I'll probably need to leave about between 4:15 and 4:30. Okay, it's just because I got this meeting in Birmingham that I need to be there by 5, or as soon after 5 as I can. So today I have to leave early, but other than that, usually till 5:15. Okay. Now, Tuesday and Thursday, I have a big, full 112 class, a good size 113 class. This one is pretty small, so I'm hoping we can move that to spring as well. Okay, and if we can, then I may have office hours in. My lunch right now has to be between 12:15 and 1:15, and then the first mini-term, my physical science class, is 1:15 to 3:45. My lab starts at 3:45, and this is Tuesday and Thursday, and goes until 5:45, and then I'm off campus at 6 o'clock.
Why is the physics class so long?
Because it's a mini-term.
Oh, it's a mini-term.
Yeah, so it has to be twice as long because it only meets half as many weeks. So it's the same number of class hours. And then my Friday is Birmingham campus, academic building, B122. And right now I have it that I'll be leaving at 11:45. I almost never leave at 11:45, but I'll adjust this if necessary. You see, already I'm here until 6 o'clock 2 days a week, 5:15 2 days a week. That has me way more than, I've got more than my 40 hours a week in these 4 days because I need to do a few extra hours for the second mini-term course. Now, in the second mini-term, the Physical Science 112 doesn't start until, I think, 3:15 because this automotive class needs it, and they don't get out until 3. So we start this class at 3:15. So it runs until 7:45 in the evening. So I'm quite a bit later on that. So I'll have more office hours on Tuesday, Thursday, second mini-term.
Is that 111 physics? Is that with Cal 1 or just?
No. This is physical science.
Oh, physics.
Yeah, the physics is on Monday and Wednesday, and I was listed. Are you taking? You're not taking, or are you taking physics this term?
Yes, sir. I'm taking it with
Dr. Bryant?
Yes, sir.
Yeah, and it's, I can't remember, is that early or late?
It's from 4:45 to 5:45.
All right, yeah, okay, it's in the evening.
And then live 5:45 to 7.
Yeah, and then next term you'll do physics too, right?
Yes.
Yeah, so you'll be through with that in the spring, and all you have is your differential equations and linear algebra in the summer.
What's the prerequisite for differential equations?
They're both technically Cal 3, but if you needed to take them in the spring, you could. We allow people to do that, but it's really better to wait until you've had Cal 3 because you need partials in both of those courses, and you'll need them before we get to them in Cal 3. So it's better to have Cal 3 first, but if some people can't come in the summertime and they're taking Cal 3 in the spring, and that's the last time we're going to see them, then we will let them take it. So, okay? Okay. So this isn't final on this. As soon as I know which of these classes, this one, and linear algebra, which of those may make or not, then I'll adjust this. Okay. Any more on my that? Okay. Well then, I guess we can get started on calculus. And the only reason I'm sort of pushing here is that we got a lot of review to do before we actually get to where we are supposed to start. You didn't realize that we were pushing. Okay. May not have realized that. Okay. I don't really think that's what I want to do, but I'll try it. This is a really loud, this is one reason we're changing books. This is a terrible support material, and it's a really awful test bank. But okay. Did you feel like your graph sketching and asymptotes, that you were okay with that? We did that at the end of the last term. Remember it? Concave up, concave down. Okay. So we'll begin, then we're going to skip 4.7, which is applied optimization. I seldom cover that. It's a good section, but I usually don't have time to cover it. Unless, well, still waiting on this to open. Ah, there it goes. So let's do the end of 4. I just want to show Newton's method because it's such a handy, useful. In fact, do you have a graphing calculator? Or have you ever used one? Okay. Have you ever used one before or seen one used? Okay. There's things on that you can choose to locate minimum values or intersections and things like this, intercepts, and what it does is use Newton's method. Newton came up with this when he first developed calculus. No one's improved on it since. I mean, this is pretty nifty stuff. Okay, so this is 4.8. And again, we're just going to do a slideshow on it. If it'll ever open. Okay. Yeah, right section. Okay. Now, since we're sort of at a kind of break point, I need to go clear my head. I've got a lot of drainage. Do you need to take a little break? Now, here is a function. It's coming up as soon as it will get here. All right, here's a function. Now, they tell you what function it is. It's a polynomial function. Tell me two things about polynomial functions. Graphs of them. Okay, that's a quadratic to make a parabola. Any polynomial, two characteristics. They're smooth, no points, no cusp or anything, always smooth, and they're always continuous. There's no asymptotes, there's no discontinuities, there's no jumps or even holes in it. So that's going to be true about this. Now, another thing about polynomial functions. Usually you use what we call the leading term test. The leading term test, you first look at the exponent of the leading term. If it's an even number, then you know that the graph is going to go up and up or down and down, depending on the sign of that leading coefficient. This is plus, this is odd. If it's an odd, that means it goes negative for negative numbers and positive for positive numbers. If that was a negative here, then it would be going in the opposite direction. It's going in always opposite directions. Okay? So, that's one thing that leading term tells you. It tells you basically the shape of the function in the long run. Up and up, down and down, up and down, down and up. Okay? Because polynomial functions always going to be one of those. If it's going to infinity, the answer is going to either plus or minus infinity. Okay? All right. The next thing it tells you is how many zeros you could have. And if this is a 5, that lets you know you could have up to 5 zeros or solutions for that function. if you set it equal to 0. However, you don't have to have 5. 5 or less. The other thing, one more thing it tells you, 1 less than this 4 would be how many turning points, the maximum number of turning points. It'll be 4 or less. Okay? Now, there's the graph. Okay? Obviously, the end behavior is right because it's an odd exponent, so it's going either like this or like that. Because it's a positive coefficient, it's going like this. When x is negative, the function is negative. When x is positive, the function is positive. Okay? So that part is true. Negative, positive. Makes sense. Okay. Number of zeros, this one only has 1. But guess what? If this is an odd exponent, it's got to have 1 because you can't go from negative infinity to positive infinity without crossing 0 if it's a smooth and continuous function, right? Or going from negative positive infinity to negative infinity. You got to cross 0 if it's smooth and continuous. So this one has at least 1, and it has only that 1. Well, how do we find what that 0 is? You can't set this equal to 0 and solve that. I can't. Okay? So how do we find that 0? Okay? Well, that's what Newton method gives us a really good way to do so. Number one, how do you get that graph? Well, you use a graphing calculator, and that basically is using something pretty close to it. But that's how you know exactly where that is. And that's what this section is going to be talking about. How do you find those zeros? Well, here's what we use. And old, clever Isaac Newton came up with this. In fact, I'm wondering if he didn't invent calculus just so he could find these zeros a lot easier. No, that wasn't it, but he made this. Okay, here's a function. And they don't tell us what function that is. Okay? What they choose some value of x. And they chose this is your x0. And then they calculate what f of x0 is. And that would be this value, right? And then they take the derivative at f0, and that's this, and where that crosses the x-axis, that becomes your next guess. Okay? Then you go up and find out f of x0, f what x1 is, and that's what we've done here. Then take the derivative of that, and it heads you here. Look at this. You went from here to here to here. Not going to be too long before you're right smack on top of that. Usually Newton's, and that's exactly what they do. That is your sequence of events. Okay? Pick any point. Well, not any point. Okay? If you had picked a point over here, like 0 would be this one. That looks like it's almost a horizontal derivative there. You never go across the x-axis to a horizontal derivative, or if you do, it may do it somewhere way out there if this is just barely greater than 0, and it may take you a long time to get back here. So as long as you can choose your first guess relatively close to what that 0 is. Okay? So that's the sequence, and you see in one iteration, 2 iterations, you're awfully close. The third iteration is going to be almost smack dab on. And you can set it, and guess what? That's what your graphing calculators are going to be doing. They're going to be doing Newton's method. Okay? So here is Newton's method. Okay? This is just for your cultural enlightenment. You won't be tested on that this term, but just so you'll know. To approximate a root of f of x equals 0. Now this doesn't work only for polynomial functions, just about any function. Choose an initial guess x0. You try to get as close to that as possible. Like, let's go back to this one. You know what I would choose? 1. Okay? And then when I go down here, I'll find a value here, do a derivative there, and we're going to go back and forth. It's not going to take you but a couple steps before you get there. 2 would work too. It might take a few more steps. Okay? What I wouldn't do was choose 0. Because guess what? 0 gives you this, and then you do a derivative here, it's going to put you way over here. You're going to get further and further from it. So that's why I say pick something fairly close. 1 would be a very good one to choose. Okay? All right. Choose an initial guess, x sub 0. Okay, as close to it as you can estimate. Generate successive approximations x1, x2, x3, and so forth, where x of n plus 1 is x of n, whatever that first guess was, okay, minus f of xn divided by f prime of xn, okay? And that's going to give you your x of n plus 1. Your x of n plus 2 is x of n plus 1 minus f of x n plus 1 divided by f prime of x. That will do it. You're going to zoom in there. As long as you get a good first guess, you're going to zoom right into it pretty quickly. That's all there is to it. And that's what your calculator does, your graphic calculator does when you tell it, find the intersection. Find the 0. Find the, whatever. That's exactly what it does. Make sense? Okay. Now, these are just showing a few that you might have some problems with. And remember, it doesn't have to be a polynomial function. Here's a trig function. Sine 3x minus cosine x. Okay? If you're wanting to find this 0, don't use pi fourths, okay? Because that is a 0. You're not going to go anywhere on that. You'll be at your 0 there. So what I would choose is probably pi eighths. I don't know if pi eighths would be exactly. I doubt if it would be, but that's what I would use. You already know pi fourths is that one. For this one here, I would use pi halves as your first guess. Now, I wouldn't use 3/8 pi because that would be over here. That's going to have you going this way, not that way. Okay? So this one will be a reasonable guess, I think. If it's not good enough, then go over another 8 pi or something like that. So you just have to use a little bit of reasonableness with it. You know, get your good first guess, and usually you can go from there. All right. Okay. Here's the only 0. It's approaching 0 here, but never gets here. If you choose your first guess here to be anything to the right of that maximum, you never go. It's going to keep going and going and going and going. Because it can't go back this way. If you choose anything to the left of the maximum, it's going to get there in a big hurry. Okay? But guess what? You can see that's the 0 anyway. But that's the thing. Don't get on the wrong side of a maximum or minimum. Because then it's going to try to take you to the next one, not to the previous one. Or it's going to take you to the previous one, not to the next one. Okay? So you have to get within the nearest maximum. Okay? So that's where you use what we already did. Find that maximum, make sure you don't pick an x0 that's beyond that. Come back this one. Okay? Now this is a quartic. They tell you what this function is. Okay? And none of these zeros are rational numbers, it looks like. They're all probably irrational. Okay? So, if I were going for this first one, I would use -2 as my first guess. That's going to get me there. For this one, I'd use -1. That will get me there real quickly. Here, 1 will get you there real quickly, 2 will get you there. If you had chosen -3, that will get you there fairly quickly. But if you had chosen -2 for this one, it won't get you back to this one again. It will never get you to that. If you chose 0.5 for this one, it won't. It'll get you this one, but not that. So you would need something always in between your max and your mins. You've got to be within that. If you get just an easy number, go for it. So that's the general idea.
You plug in those numbers to the equation?
Okay, remember what the rule was? Pick a thing, then do f of x divided by f prime of x. Okay, so since they gave us an equation for this one, let's do it. Hopefully we can do it pretty quickly. Okay, let me get my pen activated here. All right. Which one you want to go for first? The far left, the one near -2, -1, 1 or 2? You choose. I don't care.
2.
Second?
2.
2. We want to go for that one. Okay? Then let's do that. Your x sub 0, we're going to say, is 2. Okay? X sub 1 is going to be 2 minus, right here, minus, okay, f of 2 divided by f prime of 2. So that would be 2 minus, and what's f of 2? F of 2 would be 16 minus
18. No.
24 plus 2 plus 5. So let's add our positives together. That would be 21 and 2 is 23. Minus 24 would be minus 1. So that is our f of 2. Let's do f prime at 2. Well, let's first do f prime of x. What would that be?
4x
cubed
minus 12x
12x plus 1. Okay, so f prime of 2 would then be 32 minus 24 plus 1. And that would be 8 plus 1 is 9. So x sub 1 would be 2 minus, actually plus now 1, because minus and minus 1, over 9. So 1 point, well, yeah, you do that. Whatever, you can get that as a decimal number, but you see it's a little bit beyond 2. And it's not going to take long before you're going to be right on top of it. I can't look at that and tell you if that's exactly, it's not exactly, I'm pretty sure it's not exactly. There's 1 and a 2.5 right there. 2, what's you see, you've gotten closer, 2 and 1/9. Yeah, you're closer to it than you were to 2. And then you can keep doing this as many times as you want. Make sense? Okay. All right. Oh, and here is the table for that one. Okay. Let's go back a moment. Okay. This is showing you x0 of 0 and x0 of minus 1. With x0 of 0, I'm not, I mean, just looking at that, that looks like it may be on the downhill side. I think it is, because you think those should be fairly uniform. So this 0 should head you back this way, not that way. But -1 will get you there real quick. Okay? So let's choose those two, and that's what they're going to do next. Let's do those two. And you see, the first one when you choose x0, 0, then the next one's going to be -5, way over there. Okay? No, that isn't going to work too well. Okay? Let's go back and see. Yeah. There's x0. It's going to be somewhere way over here. Then you go from here and go, it's going to take you to the next here. It can't possibly take you to that. So this is going to get you it's not the best way to get there, but this will get you to this 0. If you choose 0 here. Surprise, surprise. -3 would get you there much quicker. Okay? But if you use -1, that gets you to this one. And you see, hit the wrong button. What a pain in the neck. Well, that was the last example, I think. And let's go. Oh, okay. Okay. When you chose x equals 0, that's the value, then it's going to take you way back here for your first guess. And then that's going to go up here and bring you down here, so you're going to be something on this side, -2 point something. If you choose x equals -1, that's going to get you here, go back up there, it's going to get you there real quickly. Okay? So you're going to get something slightly less than -1, greater than -1. Okay? Less than -2, greater than -1. Let's see what they got. This is where I hit the wrong button last time. There we go. And sure enough, it takes 7 steps, but it gets you to this value right here. Now that makes it look like that's an exact value. I don't know if it is or not. When you round up that way, that's pretty suspicious. It looks like it gave you an exact value. I doubt if that's exact. But you get 2.34, 2.35, that's going to be probably -2.35. Whereas this one here, 1 step got you there, and then after a few steps, you see right here you're good to 6 decimal places right there. One more would be that you're good to 7 decimal places. That is 6. That's a 6. That's a 6. And these two, wow. Yeah, I think you're about as good as you're going to get there. That's pretty close to right on the money. Probably an irrational number. That's going to be the best approximation we can get. Whereas this one, choosing a poor initial value, it only got you within 3 significant digits. After 7 steps, after 4 steps, that got you to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13 significant digits. That's better than my calculator will do. Okay? So, all right. Any questions on Newton's method? Okay, and that I think is the end of chapter 4. So what we're going to do is, let's see. Okay. Don't save. Okay. No, we're not. Say again. Right. Yeah. I wasn't paying attention. What in the world was 4.9? Our book doesn't even have a 4.9. Let's just see what it was, because this is the old slide set. Previous edition. I'm pretty sure we don't do it, but I was just wondering what it was. Oh, antiderivative. I wondered where that section was, because there is no antiderivative section in the new book. Okay? Actually, this isn't a bad thing to look at. We're just going to go through it quickly. So let's go from current slide. Because we're going to use this term over and over and over again, and I think it's a good idea to know what we're talking about. Antiderivative. Is the... I wonder if they've gotten out of using that term. I use it all the time. See, this is the first time I've taught from this edition. Ah, there it is. It's in 5.3. They give the same definition. So I'll give it to you now. Antiderivative. A function f of x, that capital F of x, is an antiderivative of little f of x on some interval a to b if f prime, capital F prime, is equal to little f. If little f is the derivative of capital F, that means capital F is the antiderivative of little f. Okay? For all the x's in that interval a to b. That's what we mean by an antiderivative. So basically you have to put your hat on backwards, okay, your derivative hat, and think of it in exactly reverse order. So let's see. Here's the general antiderivative. Like I say, these are terms we're going to use in 5, but we were just going to zoom through them there, so let's just do it here. The general antiderivative, let capital F of x be an antiderivative of little f of x on some interval a to b, then every other antiderivative on a to b, because this just says capital F is an antiderivative, every other antiderivative on a to b of the form is of the form capital F of x plus c for some constant c. All right. Making any sense the way it's written? Okay. Here's the deal. If you have a function, you know its derivative gives you the slope of the tangent line, right? But that same slope would be on this here, but that doesn't intersect. Or up here, or down here. So you see, lots of things can have that slope, okay? But that's the only one that is actually the slope of the tangent line there. So when you're going backwards and doing antiderivative, it's the function that, see another way to express that. There could be a lot of functions whose derivative, okay, let's just say it this way. Let's say that capital F of x is the antiderivative of little f of x, right? Now, and that meant that capital F prime is little f, right? Okay. Well, let's take the derivative of this function. What's the derivative of capital F of x? Little f, right? And what's the derivative of c? 0. So you see, this is also an antiderivative of that. For any value c you put in there, okay? For any value. Plus 1 million, negative 5 million. Plus 0.352, negative 7.35872. You know, any number there, they're all going to be antiderivatives of that function f of x. Because you can always put any constant to it. Okay? Because when you take the derivative of a constant, that's 0. Okay. All right. Here's a function, capital F of x. Okay? Its derivative of that function is little f of x, right? Its derivative here is that, here is that, here is that. Okay? Well, any function f of x plus c, c is a positive thing, that's just a vertical translation of this one. And its derivative here is identical to that. The slope is. That is identical to that one. This is identical to that one. And if you had a c being negative, then that one, this one, they would all be exactly the same. So that's just saying the tangent lines for any function y is equal to capital F of x, and y is equal to capital F of x plus just some constant, at every point, the slopes are going to be the same. So both of these would be antiderivatives of little f of x, right? Because their derivatives are the same. Okay, so that's illustrating that last point. All right. Now we do, so this is basically, what in our book is going to be 5.3, okay? That showing up here is 4.9. Just a weird place to put it. I think I like it better in the new book, okay? But here's your definition of an indefinite integral. All right? This is an integral symbol. We haven't formally defined that yet. The integral of f of x dx is its antiderivative, which is capital F of x plus c. Okay? Okay? We don't know what little f is, we don't know what capital F is, but that's the definition of an indefinite integral. Now, what do we mean by indefinite? We don't have values as starting and ending points here. Anytime you have just an integral sign, that means indefinite integral. Whatever its antiderivative is, add c to it. What that means is this thing, derivative of this thing, has to be that. F prime of x is equal to c. That is equal to little f of x. But f derivative of whatever this is, whatever value c is still going to be f of x. We say that f of x plus c is the general antiderivative or the indefinite integral of f of x. So if you don't have limits here, you always put a plus c. Always. That's basically all it's saying. All right. So let's look at some antiderivatives. Okay? The integral of x to the n. Now, I don't know if this is helpful to you or not, but this is how I like to remember it. Okay. Let me get my pen back. Okay. What if we had x to the n? Let's give that a name. Let's call it g of x. Why not? Okay. Now, what if I told you to take the derivative of that? What would you do?
G would be nx.
N times x to the n minus 1. Okay, what did you do? You took the coefficient and multiplied it by the polynomial to one less value. So if you think about it the other way, you took x, decreased it by 1, but multiplied it by its coefficient. Okay. Now, if you're integrating x to the n, think backwards. Okay. If you're integrating, that means you're going to increase that exponent by 1, And rather than multiplying by the exponent, you divide by, divide by the new exponent. Not the old one, the new one. So, see, it's an anti-thing, okay? Rather than reducing by 1, you increase by 1. And rather than multiplying by an exponent, you're dividing by the exponent, but not the previous exponent, the current exponent, okay? Here you did the previous exponent, here you do the current exponent. So that gives you that value, and because it's indefinite interval, always ends. Now guess what? That is no good if n was minus 1. Will not work, because then you'd be dividing by 0. Not a good idea to do, right? So this works for any n in the world except minus 1. So either later in this section or when we get to the next chapter, we're going to find out another definition for when that's n to the minus 1, which I think you know already whether you realize it or not. Hold on, don't worry, you'll get there. Okay, so there's your power rule for integrals. Fairly similar to differentiation, except do it backwards. Rather than decrease by 1, you increase by 1. Rather than multiplying, you're dividing. And you're dividing by the increased. Okay. Now, remember I said, oh boy, they're jumping right into it, aren't they? That was good for as long as x wasn't n wasn't negative 1, remember? Well, this is what your function is. If n is negative 1, then it's x to the minus 1, which is 1 over x, right? 1 over x. Okay. And here you put your hat on backwards again. What you're trying to do is think of a function whose derivative is 1 over x. You remember one? Some function whose derivative is 1 over x. Log x, exactly. But it has to be absolute value because you can't take the log of a negative number. So basically, this is the graph of log x. This is the graph of log negative x, because when x is over here, you'd have to negate the x to be able to take a log of it. So this would be the graph of log absolute value of x. And sure enough, its slope would be 1 over x here and minus 1 over x there. So, again, you think, what would be the function whose derivative would be 1 over x? And that would be the antiderivative. Okay. And that would be log x. All right, so here they give it to, whoa! All right, this is going to be a little confusing for now, just because of the way they changed the thing. What I think I'll do from this point on is ask you to help remind me. We'll start next time in chapter 5, okay? Now, when we get to 5.3, which is the antiderivative, or integrating the indefinite integral, if there's not a good slideshow for that, we'll come back to 4.9. Remember that, 4.9, okay? So, one thing I forgot to do, I thought of it when I went in the hall and then forgot when I came back. I forgot to go over safety. You remember safety from last term?
If there's somebody assaulting school.
Say that again?
if there's like somebody with a firearm,
Okay.
we lock that door and hide the spec wall.
Okay, you remember that one. Why do you remember the firearms first? I mean, that's the last thing I did, but that's what everybody remembers, okay? What do we do in case of fire?
We go down the stairs, up that exit, go down there.
Right, and go out to that parking lot down there. Okay, what do we do in case of severe weather?
Go to this hallway, right?
What's that? Yeah.
We go down the stairs to the hallway right there.
Okay. Whereas for an interior emergency like fire, chemical spill, or something like that, you go down and out. When it's an external emergency, you go down and in. Lowest level, interior rooms. So that would be going out of the door, down the stairwell, as low as you can go, and then go interior. So that would be...
Towards the library?
Yeah, but the library, many of those rooms have external windows. Any part of the library that hasn't got an external window, that would be okay. The classroom down there, the restrooms down there, the dean's office down there, those would be safe for a weather emergency. Tornado, severe thunderstorm, that kind of stuff. You get down and in. Internal emergency, fire or chemical spill, you get down and out. Okay, get out. And then firearm, you lock yourself in, like you said, and get somewhere you're out of sight, quiet, out of mind. Yeah. You remember all that from before? Yeah. I meant to do that, and I forgot to. Okay. So, where are we going now? Let's escape, discard, and... Okay.
Go see the solar eclipse.
What's that?
So I'm going to go downtown to go see the solar eclipse.
Oh, okay.
That
We're,
starts at noon, right?
the very beginning of it's noon. The maximum is about 1:30ish,
Yeah.
and it'll go up until 3. About 3, a little before 3 probably. We're going to be looking at it some outside here.
I went to Mount Brook last night to get the glasses. It's like there's nowhere I can find them. So
Right.
there.
Did you find some?
Sir.
Oh, you did?
Yeah.
Okay. We called around lots of places, or Karen looked on the internet. They were all sold out.
Yeah,
One place in Mountain Brook, yeah, Smith's,
variety, something like that.
yes, Variety was by Smith's or Smith's Variety. They had gotten a new order in yesterday, but we found out about it at 6:25 and they closed at 6. Yeah.
Oh, I called in. They actually closed till 8:30.
Really?
Yeah.
Oh my goodness, we could have
I got home
gone.
from Atlanta from my brother's soccer tournament at like 6:30. I was like, I saw the Facebook page. I was like, man, I was like, this still gotta be open. It's like I saw like they posted like at 7, and then people started commenting like, oh, there's still like 1,000 left, this and that. So I was like, I'll try to call. I called them, didn't go through, so I was like, oh, it must be closed. And like my conscience didn't let me go through, so I was like, I called them again, and then they answered. And they're like, yeah, we'll be closing at 8:30 tonight.
Oh, really?
Yeah.
What time did you get there?
I got there at 8:05.
8:05. How many left did they have?
They still had I think they still had like 800 left.
Really? Oh man, we could have gotten them.
Yeah, so I don't know if they have any more left. It's like,
No, it's too late now. I mean, I wouldn't run over there and get them. But what I did, I brought some. Have you ever heard of a pinhole camera?
yeah, I heard.
Okay. We made a couple last night, and I brought materials to make some more, and we're going to look at them out there. We're not going to look at the sun, but we're going with the sun. It's a cereal box.
So like,
Yeah, exactly. A white piece of paper in the middle of the box, and then you look and you'll see it right there. The image of it, not the sun itself, but the image of it. So I'm going to have that out there for people to look at. We're going to try some other things too. It's going to be fun, I think. So where are you going to watch it?
I'm going to be going to Vulcan Park.
Vulcan Park, nice.
I gotta go pick up my siblings from home real quick.
Pick up what?
Pick up my siblings from home.
Oh, I see. Okay.
Yeah. Or I think my sister went to school, so I gotta go check her out.
Right.
And then my brother didn't go to school, Because he thought it was going to be excused, but it's not. So.
Yeah. Which one was in the soccer tournament?
Oh, my brother, he's 16.
He's what, 16?
He's 16 years old.
Okay.
Yeah.
Are you the eldest?
Yeah.
Oh, I see.
The eldest.
Leading the pack. Huh?
Yeah. Well, they're trying to follow.
Okay.
I'm the good kid, so
Yeah.
there's a lot to live up to.
Yeah. No, I'm doing great.
I'll see you Wednesday.
Okay. Enjoy it.
Thank you. And I'll try to do my payment tonight.
Okay. Good deal.